Now let us discuss a thermodynamic temperature scale. So you can take a heat source at TH and a heat sink at TL, and then you have a heat engine. So it is takes a heat QH and produces work QH minus QL. That means it rejects QL and produces work QH minus QL. This is perfectly possible. See, the Carnot principle, the second Carnot principle is like this. The efficiency of all reversible heat engines operating between the same two reservoirs are same. We have already proved this principle. That means if you take any Carnot engine between these two temperature sources, the efficiency will be same. In other words, the efficiency depends upon the TH temperature of this heat source of the reservoirs, TH and TL. This is what it implies. So efficiency of any heat engine can be written like this: 1 minus QL by QH. So QL by QH is equal to function of TH and TL. So this is the efficiency. So efficiency is a function of TH and TL. So that means 1 minus QL by QH is equal to function of TH comma TL. So QL by QH is equal to 1 minus function of TH and TL. Okay. So this can be written as a new function f dash. Okay. F dash TH and TL. Right. This is also a function. So see this QL by QH you can write like this. This instead of this function TH TL you can write phi of TL and phi of TH. Okay, so this is the only possible way you can write this function. Okay, right? So this QL by QH is equal to depends upon phi of TL and TH. Now, okay, so we have already seen that this Q1 by Q2 is a function of T1 and T2 because it is what the second Carnot principle implies. And Q2 by Q3 is equal to function of T2 and T3 and Q1 by Q3. Okay, so this is a thermal energy reservoir at T1. So you have a reversible heat engine working between these two temperature reservoirs, thermal reservoir that is takes in heat Q1 from T1 and rejects Q2 at T2 and produces work. And you have a reversible heat engine C, it takes in Q1, produces work here and rejects Q3. Right. So this reversible heat engine C works between T1 and T3, and here you have a reversible heat engine B, it works between T2 and T3. It takes in Q2 and rejects Q3 and produces work. Okay. So this reversible heat engine B works by taking in Q2, the heat released from the reversible heat engine A. So now coming back to this equation. So according to second Carnot's second principle, you know Q1 by Q2 is equal to function of T1 T2 and Q2 by Q3 is a function of T2 T3. Q1 by Q3 is function of T1 T3. And Q1 by Q3 is equal to, you can cross multiply these two. Okay, that is Q1 by Q2 into Q2 by Q3 is equal to function of T1 T2 into function of T2 T3. Okay, so this will become, so we already know that this is equal to function of T1 T3. So function of T1 T2 into function of T2 T3 is equal to function of T1 T3. So this will become Q1 by Q3 is equal to Q1 by Q2 into Q2 by Q3. So this is equal to function of see, this can be this is possible. See, function of t1 t2 into function of t2 t3 is equal to function of t1 t3. That means this does not depend on t2. This can be possible only this function is like this. That is function of t1 t2 is equal to phi of t1 by phi of t2 into function of t2 t3 is equal to phi of t2 t3. So this is equal to phi of t1 t3. Okay. See, this is how we reduce this q1 by q2 is equal to t1 by t2, or q1 by q3 is equal to t1 by t3, just like this. That means phi of t1 can be written as t1 itself. There is no problem. And we have already discussed QH by QL is equal to phi of TH and phi of TL. So this can be simplified. That's the best approximation is QH by QL is equal to TH by TL. Okay, this is how you find the see the relationship between heat and temperature.